Binomial example. An MCQ test has questions with 5 answers to each question. If a student answers all questions randomly, what is the probability of getting 4 of the 10 correct and passing the test? So using the binomial formula, we can apply that to this case. So it's getting 4 correct out of 10. So you can see that the first term there, n factorial over n minus x factorial times x factorial, is simply 10 factorial over 4 factorial over multiplied by 10 minus 4 factorial, which is 6 factorial. So the factorials are straightforward. 10 factorial is 10 by 9 by 8 all the way to 1, and 6 factorial is 6 by 5 by 4 all the way to 1. And that first term comes out at 210. You see in the final answer. And then the second term is p to the power of x, q to the power of n minus x. So p is the probability of getting it correct, which is 20.2. So to the power of 4 multiplied by 1 minus p, 1 minus 0.2 to the power of 6. And that comes out at 0.016 by 0.262144. So the final answer is 0.881 or 8.8%. So that's the probability of a chain of events which are independent, whereby any 4 of the 10 are correct. It's 8.81%. That formula gives us to calculate the answer for where x is equal to 4. So you can see in our frequency table on the right, we get the result for one of the 11 possible outcomes. So the outcomes are no questions correct, 1 question correct, all the way up to all 10 questions correct, and we have the correct. We've got the frequency for just one of those outcomes. So the probability distribution is the result for all possible outcomes. So when we completely fill out that empty column, we have a probability distribution for the trials, and we can use that probability distribution then to answer more important questions. For example, what is the probability of passing the multiple choice test? That means what is the probability of scoring 40%, i.e. 4 or more? That means you have to work out whether we scored 4 or 5 or 6, etc. So we've got to calculate the probability where x is greater than or equal to 4. That's a number of different probabilities joined together. And it's also a cumulative frequency problem. So we're already familiar with doing cumulative frequency problems, and that's an assignment. So do the binomial assignment that's provided.